Okay, as you look at your decision tree, there's a big question that we have. And that question is, what do we do about triangle scenarios that we have not discussed yet? We have angle, angle, angle. We have angle, angle, side. Angle, side angle, and side, side angle. But what about these two scenarios of side, angle, side, and side, side, side? Suppose that we had a triangle that was of this shape. Triangle where we had A, B, and C. This triangle was 35 degrees for angle A. Side C was 10, and side A was 11. Why can't you use the law of sines in this scenario? You don't have the angle and its opposite side. Because you don't have the angle and its opposite side, you need to try something else. So therefore, we look at this example. Whoop, wrong stuff. Wrong class. Okay, many triangles are not right triangles, but rather oblique. We've already discovered this. We are able to use the law of sines for most triangles, but what about triangles where we are given all three sides? What about triangles where we are not given the opposite side? Let's use what we know about right triangle trig in order to derive a way of solving these oblique triangles. Yay, Mr. Danton, thank you. I won't give you the formula. I'm going to show you where the formula comes from. That's A, that's C, and we would call this B. Now, I've made a right triangle in order to create some work here. The problem is that we are not given an angle on its opposite side. So therefore, like before, I didn't have to use this bottom side we'll call B, but now I do. So we're going to divide this up. We're going to call this side X, A for the day. Who could come up with the length of the other side? B minus X. That's all right. So I have X and I have B minus X. If you add those two lengths together, what do you come up with? You come up with B. And so that's why these lengths work. Okay, simply use a substitution. So I'm going to write two expressions now. The first one is x squared plus h squared is equal to c squared. And the second expression, all right, is b minus x quantity squared plus h squared is a squared. What do you notice about these two expressions? What do they both have? H and x. And so we need to get rid of these pieces. We could get rid of the h squared pretty easily. H squared is equal to c squared minus x squared. And h squared is equal to a squared minus the quantity b minus x. If they're both equal to h squared, then they're both equal to each other. So now I can write this expression. C squared minus x squared is equal to a squared minus the quantity b minus x. What did I get rid of? Beautiful. Now I just have to get rid of the x. So let's do that. C squared minus x squared is equal to a squared. Now I have to multiply that out. Ooh, that looks scary. What do you think? Will it be a positive b squared or a negative b squared? Negative b squared. What's in the middle? 2bx. Have to double the middle. And then on the end, will be positive or negative? Plus x squared. No, minus. So when you square the negative x, you'll get a positive x squared, and you distribute your negative, and you get minus x squared. What do you notice? You can get rid of the x squareds. So now I have c squared is equal to a squared minus b squared plus 2 times b times x. Oh, I was so close. My goal is to get rid of the h's and the x's. I got rid of the h's and almost all the x's, but I got this one left right here. Can we just erase it? Okay, all right, we'll erase it. We'll do raw mathematics for the rest of the year. No, get it. Shoot. Oh boy, what should we do? How do I get rid of it? You guys are going to have to come up with it. I'll give you some hints. Oh, man. Okay. All right, so I just need an expression that involves cosine. Not necessarily cosine, but I need an expression that involves x. And as I look at x here, I'm going to choose angle A. I don't want to use x and h because that would involve tangent, and I don't know h. Furthermore, I can't use x and a because a isn't part of the right triangle. But x and c, now that's reasonable. And it's cosine that deals with x and c given the cosine of a. So I could solve for x by multiplying both sides by c. So c, cosine of a, is equal to x. And now I have a new expression. C squared is equal to a squared minus b squared minus 2 times b times, plus 2 times b times c times the cosine of angle A. So you can see we've gotten rid of the x's, we've gotten rid of the h's, so now we have this type of formula. This isn't the way that it's normally written. It's written just a little bit differently. They add over the b squared and subtract this over. So it becomes c squared plus b squared minus 2bc times the cosine of a is equal to that a squared. And now would be an example of a formula for the law of cosines. And so, again, I don't want you to think that it just comes out of magic and there's no way to derive it. We just did it right here. I'm not going to ask you to do that on the test, but I do want you to see where it comes from. So the law of cosines can be expressed 3 different ways. Number 1, you can have c squared is equal to a squared plus b squared. Hey, that looks like what? And so the law of cosines is just the Pythagorean theorem, except we subtract something off. We subtract off 2ab cosine of c. I'm going to change it. What if I put it as b squared? Then what would I have? A squared plus c squared minus a squared is b squared plus c squared minus 2bc cosine of a. And that's what we had derived on the other side. It just takes on different forms depending on what variable you're working with. So you don't have to even memorize those for the test because I give you the formulas right here on your graphic organizer, your decision tree. So let's put it to use. We try example 1. Solve the triangles given the following conditions. We have angle A. Yep. Good day to go outside, folks. Wow. Yeah, lunch tables all the time. Okay, so A for the day. Which 6 scenarios do I have here? Which of the 6? I have a side angle side. Now, if you have side angle side, you don't have an angle and its opposite side. So therefore, one solution, use the law of cosines. It is a triangle congruence theorem, so we know it's going to work out. We have to use the law of cosines. Never mind the rest of it. I'll explain that as we get to the problem. So we set it up. Angle A, angle B, angle C, side A, side B, side C. So I'm going to solve for which side? A, I want to know the opposite side. So my formula is A squared is equal to B squared plus C squared minus 2BC times the cosine of angle A. Here's the nice thing. You can just plug this straight into your calculator. You don't really have to do any simplifying. Your calculator understands that order of operations. So we have A squared is equal to 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 26 degrees. I'm going to type it in just like I see it. 12 squared plus 15 squared press enter. Is that my answer? Why not? Square root 6.74. Second, and then there's that negative key, and you see that in yellow it says ANS. So I've got A is 6.74. You know that B is 12. You know that C is 15. And we know that angle A is 26 degrees. So I just have to find 2 angles left. What do you think you use to find the other 2 angles? Law of sines. Please pause and think through this now. This is the last kind of critical thinking piece you really have to engage in for this lesson, okay? Is it possible that there's an obtuse angle in this triangle? If so, which angle would it be? It would be angle C. If we set up the law of sines, does sine know whether you are an obtuse angle or an acute angle? No. Sine is positive in the first and the second quadrant. If you come up with 80 degrees, it might be 80 or it might be 100. You don't know which one it is. So let's not find angle C right away. Instead, let's find the smaller one. True or false? I know that B is an acute angle. True. If it's not the biggest angle, it has to be an acute angle. So let's find B first. So the decision tree says, one solution, use the law of cosines. When you use the law of sines to find one of the missing angles, start with the angle opposite the shorter. Whoa, I'm in the wrong spot. This one. One solution, use the law of cosines. When you use the law of sines to find one of the missing angles, start with the angle opposite the shorter of the 2 sides. This is where you're at. Okay? So I look at my triangle. Which angle is opposite the shorter of the 2 sides? B. So I start with angle B. Sine of angle B over 12 is equal to the sine of 26 over 6.74. Now, do a cross multiply and solve there. 12 sine of 26 divided by 6.74. And is that my answer? You're finding an angle, so you have to sine inverse the answer. I came up with 51.3. I know that that's acute because I know it's a shorter angle, a smaller angle than 90 degrees from the work I've done. How do I find C now? Subtract 180, 180 minus 51.3 minus 26, and I get 102.7. Here's the problem. When you set out to do these problems, if you don't follow along with the decision tree I gave you, and you decide to solve for C first, you'll come up with 77.3. You're like, why would I come up with 77.3? That's because the sign of 102.7 is the same as the sign of 77.3. They're the same values. Your calculator doesn't know the difference. That's why you have to pay attention. Some people will look at this and they will then say to me, I will put it back up at the end of the hour so you guys can check, okay? All right, we go to this piece. Last example, A, B, and C. A is 10.5, B is 9.1, C is 12.4. A, B, C. Which of the six? Side, side, side. I do not have an angle in its opposite side, so therefore I must use the law of cosines. The question is, where do we start? Is it possible that there's an obtuse angle? If there's an obtuse angle, which one would it be? It would be C. Now, here's the beauty of the law of cosines. Is sine positive or negative in the first quadrant? Is it positive or negative in the second quadrant? And we've discussed that that's why sine can't tell the difference between acute or obtuse. Cosine, is cosine positive or negative in the first quadrant? Positive or negative in the second quadrant? Oh, so does cosine understand whether it's acute or obtuse? Yeah. So if I come up with cosine of theta is equal to 0.2, it will be acute. If I come up with cosine of theta equal to negative 0.2, it will be obtuse. So I will force out the obtuse angle right now if there is one. So which angle do you think I should solve for? C, exactly. And so the decision tree even says right here, just start by solving for the angle opposite the largest side. That's the easiest way to go about the side, side, side scenario. So I look for the largest side. It is C, so I use C squared equals A squared plus B squared minus 2AB times the cosine of angle C. Plug it in. 12.4 quantity squared is equal to 10.5 squared, 9.1 squared. 2 times 10.5, 9.1, cosine of C. This is where you completely forget the rules of order of operations. I don't know why it happens, but every year, it's like we've never done order of operations before. What comes first? Addition, subtraction, multiplication, division? What do we do? You must take care of your multiplication, correct? So look at this. The negative 2, the 10.5, the 9.1, that is all multiplying the cosine of C. So what I'm going to do is I'm going to subtract these pieces over here, and then I'm going to figure out what that is and divide it off. So I'm going to have 12.4 squared minus 10.5 squared minus 9.1 squared is equal to 2 times 10.5 times 9.1 times the cosine of C. Negative. So, we take out our calculator. We simply just go through. So on the left side, I get negative 39.3. On the right side, I divide, will I come up with cosine being positive or cosine being negative? Positive. So therefore, is it the first quadrant or second quadrant? Get 0.20565. You guys said that's going to be the first quadrant, so it'll be acute. I'll cosine inverse the answer. I get 78.13. So that means that that's my largest angle. So there's no obtuse angle at all. My other sides, side A is 10.5, side B is 9.1, side C is 12.1. How do I find angle A and angle B? Law of sines. Sine of 78.13 divided by 12.4 is equal to the sine of A over inverse the answer, 5596. Subtract from 180. Today you practice the law of cosines. But tomorrow, I give you 6 triangles in class. And I don't tell you if it's angle, 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 or angle, or side, angle, side. You determine that and try to figure out which path it goes down. And so tomorrow, I think, is probably the most critical day for you to say, I know what I am doing. And if you got tomorrow figured out, you have a chance to ace this test. But if you don't figure out tomorrow, unfortunately, your score could really, really dwindle. So that's my kind of warning to you as you move forward. Here is your assignment. (6.5), page 518, numbers 9 through 18. I'm going to let you write that down, and then I'm going to pull up the screen that shows the answers from Friday's assignment so you can check to see if you're reasonable or not. And then I'm going to answer Kelsey's question. And then Cam's. Everybody got it written down? Okay, there you go. From 6.4, that's how many solutions you should come up with from your Friday's assignment so you can check to see if you think you're on the right track.